Module 4, Lesson 31, Problems in Mathematical Terms. Looking at our learning targets, I can write and solve equations and inequalities involving real-world problems. I can analyze dependent and independent variables using graphs and tables and relate them to an equation. We have been working on this. We just weren't super clear that we were working on it, so please don't stress. These are big words, dependent and independent, but it will be just fine. I can statements. For a given situation, I can identify the independent and dependent variable. I can write an equation to represent the situation. I can create a table with the independent variable in the first column and the dependent variable in the second column. I can complete a table by substituting values for the independent variable and finding the resulting value of the dependent variable. Before we go any further, I want to just briefly discuss what these dependent and independent variables are. A variable, as we already know, is a value in an equation that can change. For example, 2 plus r. So this is a variable. An independent variable is a variable that when it changes, it causes another variable to change. So for example, maybe I say that 2 plus r is equal to the total. So if I have r is 1, the total is 3. If I have r be 2, then the total is 4. So this variable right here changes, and when it changes, it causes this variable to change. We call this the independent variable, and the variable that it causes to change is called the dependent variable. Or another way of thinking of it, this dependent variable depends on the independent variable. We can't figure this out until we know what this is. So it's a simple cause and effect relationship. This changes and causes something else to change. For example, if I were trying to decide how many cookies to buy for a party, I would say, well, that depends on how many people are going to come. So the number of people coming is an independent variable. That will change, and it will tell me how many cookies I need to buy. The number of cookies depends on the number of people. Cookies is a dependent variable. Example 1, and we're going to go through this very carefully. There's a lot of steps that we're looking at, but once we do this a couple of times, it will really feel comfortable. Marcus reads for 30 minutes each night. He wants to determine the total number of minutes he will read over the course of a month. He wrote the equation T equals 30D to represent the total amount of time he has spent reading, where T represents the total number of minutes read and D represents the number of days that he read during the month. Determine which variable is independent and which is dependent. Does the number of days depend on the time that he's read, or does the time that he has read depend on the number of days? Well, most people would say, well, the amount of time that I've read, that kind of depends on how many days I read. So we would say that the days are independent and are going to decide how long he's read. So the first thing we've decided here is that the days are independent and the time is dependent. So if I read 1 day, this is how many minutes I read. If I've read 15 days, this is how many minutes I've read. So if we're making a table, how many columns would we have? Well, hopefully you said 2, because we need to keep track of how many days we read, and we need to keep track of then how many minutes we have read. When we set up a table, the independent variable goes in the first column, and the dependent variable goes in the second column. So my independent variable is the number of days, and my dependent variable is the time in minutes. So independent and dependent, I've already been over those. Independent variable changes, and when it does, it affects the dependent variable. So the dependent variable depends on the independent variable. So that's at least 3 times now we've talked about what this means. So in this example, which would be the independent variable and which would be the dependent variable? Well, we've already decided that the time is going to depend on how many days I read. If I didn't read any days, I read no time. If I read 15 days, that's going to change the amount of time that I read. So the dependent variable is the total number of minutes because it depends on how many days Marcus reads. The independent variable is the number of days that Marcus will read. So we have the days and we have the time. Now the time, the total amount of time is equal to 30 times the days. It says it right there in the equation. So I have done a little substitution here. I have the days and I have 30 times the days, and 30 times the days is equal to the time. The number of minutes read shown in the table is always 30 times the number of days. So the equation would need to show that the total number of minutes read is equal to the number of days times 30. So let's label each of our columns. Number of days with D and the total number of minutes read, which is 30D. Total minutes is T, which is equal to 30D. And I like putting lots of information in my table headings. And if you had already written down what I had written down, that's no big deal. Just come down to the next row and it's fine. So we need to now complete the table. So if I read, it says for the first 7 days. So day 1, day 2, day 3, day 4, day 5, day 6, and day 7. Times 30, times 30, times 30. Now I'm drawing the arrows so that you can see how I'm getting the numbers. Some students are just going to count down the column by 30s. I would prefer that what we do is say we had 4 days, 4 times 30 is 120. We had 5 days, times 30 is 150. We had 6 days, times 30 is 180. We had 7 days, times 30 is 210. It's important that we start to use this relationship right here, this equation, to help us solve problems. The great thing about what we're doing here is I can pick any number of days. What if he read 50 days? Well, 50 times 30 is 1,500 minutes. So be sure to use this powerful relationship between the columns instead of just always going straight down the rows. All right, let's look at example number 2. Kira designs websites. She can create 3 websites each week. Kira wants to create an equation that will give her the total number of websites she can design given the number of weeks. So somebody's going to say, if you work for this many weeks, how many websites can you design? Determine the independent and dependent variables. So first thing I need to do here, I'm going to put a little dot. Create a table to show the number of websites she can design over the first 5 weeks. Finally, write an equation to represent the number of websites she can design when given any number of weeks. So first question is, what is the independent and dependent variables? Well, the way this problem is set up, it sounds like I will decide how many websites she designs based on the number of weeks. So I think weeks is going to be my independent variable. And I think my sites, the number of websites, is going to be my dependent variable. It says that I need to show the number of websites she can design over the first 5 weeks. All right, so I've got my number of weeks is one column, and I've got the number of sites is the second column. Because I decided weeks was independent, it's in the first column. Because I decided that the sites was dependent, it's in the second column. And it says I'm supposed to do the first 5 weeks, so 1, 2, 3, 4, 5 weeks. And it says that she does 3 every week. So if she does 1 week, she's got 3. If she does 2 weeks, she's got 6, 2 times 3. If she does 3, she's got 9. If she does 4, she's at 12. And if she does 5, she's designed 15 sites. Now the last thing I'm supposed to do is write an equation to represent the number of websites she can design when given any number of weeks. So we're going to write an equation using variables. So I know that I have the number of weeks, and I know that I have the number of sites. So W is the weeks, and S is equal to the sites. And I need to ask myself, what am I doing to get from this first column to the second column? What is mathematically happening that is taking me from the number of weeks to the number of sites? And what's happening, I can see every single time I am multiplying by 3. That's not changing. This changes. This changes. But this 3 here, this times 3, that doesn't go anywhere. It remains the same. So I have a variable because the number of sites is changing. I have a W because the number of weeks is changing, but I am always multiplying by 3. That's a constant. That's not changing. So I can say that the number of sites is equal to the number of weeks times 3. And now I can pick any number of weeks and figure out how many sites can be designed. So we have gone from specific situations here, a given number of weeks, to a general situation expressed as an equation. Very powerful. All right, and I have actually gone through this right here. So I'm just going to advance through each of these because we did this already. All right, example number 3. Priya streams movies through a company that charges her a $5 monthly fee plus $1.50 per movie. Determine the independent and dependent variables. Write an equation to model the situation. And create a table to show the total cost per month given that she might stream between 4 and the total cost per month given that she might stream between 4 and 10 movies in a month. Now we have something in here called a flat fee. This $5 monthly fee. First question is that a variable? Is that going to change every month? Or is it going to remain the same? The answer is it's not going to change. It's not a variable. It's a constant. The $5 fee is neither. It is not an independent variable. It is not a dependent variable. It is a constant. So I have a $5 which is going to be a constant, a value that does not change. Now we have another value that does not change, and that's the $1.50 per movie. That is also a constant until they change the price. But even then it's going to be a constant. The $5 flat fee is neither. It is not causing the change in the dependent value, and it is not changing. Instead, the $5 flat fee is a constant that is added on each month. All right, so the independent variables, the dependent variable, and the equation. All right. So I know that the $5 and the $1.50 per movie, those are constant. What is going to change is how many movies she watches and how much money she's going to have to spend, the total cost of her streaming plan. So which one of these causes the other one to change? And I'm thinking that what happens is she watches different numbers of movies, and that changes how much she has to pay every month. So I feel like the number of movies is independent, and I feel like the cost is dependent. How much I have to pay every month depends on how many movies I watch. Now, thinking about the equation here, this one is definitely a little bit more challenging. Well, we know that every month she's going to have to pay $5. That's a flat fee. Even if she doesn't watch any movies, she still has to pay $5. So I've got $5. Have to have that. Now, the other part of her subscription is how much she pays for her movies. Now, it's $1.50 for every movie. So if she watches one movie, it's $1.50. If she watches two movies, I'm going to double that and have $3. She watches 3 movies, I'll triple that and I'll have $4.50. So this is the cost of the movies. The total cost of her subscription is the flat fee, the $5, plus the cost of the movies. The flat fee doesn't change, but finding the cost of the movies, I'm taking $1.50 and I'm multiplying it by every one of the movies that she watches. And if I add those together, I will have her total cost for the month. So I have the number of movies and I have the total cost. And it says we're supposed to do 4 and 10, so I've got 4, 5, 6, 7, 8, 9, and 10. And this is my equation that I can use to find my total. So I could actually, and maybe this would be helpful, I'm going to add a third column to my table here. And I'm going to have this be the flat fee. She pays $5 every month. And we've got the movies, which is the price of the movies is going to be $1.50 per movie. Over here I've got the number of movies that she'll watch. 4, 5, 6, 7, 8, 9, 10. So the flat fee is in dollars. That price doesn't change. The price for the movies is going to change. So I've got 4 times $1.50. $1.50 times 4, well, let's see, that's going to be $4 plus 2 more dollars. That's going to be $6. And if I watch 5 movies, that's $1.50 more, so that's $7.50. And if I watch 6 movies, that's going to be another $1.50. And if I watch 7 and 8 and 9 and 10, and my total cost is going to be my flat fee plus this $1.50 per movie. So add these two things together. And I've got 11, 12.50, 14, 15.50, 17, 18.50, and 20. Now, as I said at the beginning of this problem, this one's a little bit more complicated because we aren't just adding two things together, we're not just multiplying two things. We have two things happening. We have this flat fee, and then we have this changing number of movies. Sometimes in a complicated problem, it's helpful to break it into smaller pieces. Here's the number of movies that she's watched. Here's how much my flat fee is every month. This is what it's going to cost just for the movie rental. And if I combine those together, I have my total cost for the month. So this is my total, which is equal to $1.50 per movie plus my $5 flat fee. Great question. Why didn't we do 5 times the number of movies? Because this would be $5 per movie, which the problem clearly says it's $1.50 per movie. It's a $5 monthly fee, flat fee, doesn't change, and it's supposed to be $1.50 per movie. So this equation is multiplying the movies by something more expensive. Now, if you wanted to pay me that amount of money, I could be okay with that. You know, if you want to pay me $3.50 extra for your movies, I could probably live with that. All right, complete the table. I've already done that. All right, looking at a few exercises here. Sarah is purchasing pencils to share. Each package has 12 pencils. The equation n equals 12 times p, where n is the number of pencils and p is the number of packages. So this n here is the total number of packages. And this is the total number of pencils. Okay. Can be used to determine the total number of pencils Sarah purchased. Determine which variable is dependent and which is independent. Oh, and here I'm going back and rereading, and I have these reversed. N is the number of pencils. And so this other side is the number of packages that she purchased. Which variable is dependent and which is independent? Well, the total number of pencils is going to depend on how many packages I bought. If I bought 1 package, I'm going to get this many pencils. If I buy 2 packages, I'm going to get this many pencils. So I'm going to say that my packages are independent and my total pencils are independent. Sorry, dependent. Total pencils, dependent. Make a table showing the number of pencils purchased for 3 through 7 packages. So I'm going to use the variable p for packages, and I've got my total is going to be equal to 12 times my packages. I'm just using my equations here. And let's see, packages is p and n is equal to 12p. There we go. So I've got 3 packages, 4, 5, 6, 7 packages, and 3 times my number of packages is 36, 4 is 48, 5 is 60, 6 is 72, and 7 is 84. So this exercise was definitely a little bit easier than that last example. Nice, easy, multiplicative relationship here. Let's look at another exercise. Charlotte reads 4 books each week. B is the number of books she reads each week, and W is the number of weeks that she reads. Determine which variable is dependent and which is independent. Then write an equation to model the situation and make a table that shows the number of books read in under 6 weeks. Okay, so does the number of books depend on the number of weeks, or does the number of weeks depend on the number of books? The way I read this is that she reads 4 books each week, so the number of weeks is going to tell us how many books she's read. If she read 1 week, she would have 4 books. If she read 2 weeks, she would have 8 books that she's read. So I hear the weeks are an independent variable, and I hear the number of books is a dependent variable. And it says I'm supposed to have under 6 weeks here, so 1 week, 2 weeks, 3 weeks, 4 weeks, 5 weeks. I'm going to use W for my number of weeks, and I'm going to have my number of books be equal to 4 times the number of weeks. Now, how did I get 4 times the number of weeks? This is a ratio relationship. 4 books each week. That's a ratio of 4 to 1. So the books are 4 times the weeks. Thank goodness we did ratios, right? So now I can do 1 week is 4 books, 2 weeks is 8 books, 3 weeks is 12 books, 4 weeks is 16 books, and 5 weeks is 20 books. Let's look at another one. A miniature golf course has a special group rate. You can pay $20 plus $3 per person. Now, the little hairs on the back of my neck stood up and said, whoa, just a second here. This sounds like that problem with the movie stuff where we had a flat fee plus $3 per person. So this one sounds like there's going to be more here than just one step. You can pay $20 plus $3 per person when you have a group of 5 or more friends. Let F be the number of friends and C be the total cost. Determine which variable is independent and which is dependent, and write an equation that models the situation. Then make a table to show the cost for 5 to 12 friends. All right, now I just heard here there is a $20 flat fee. So I'm going to have my flat fee here. I'm going to add a column here. It's $20, flat fee. So I know I'm going to write that down. I always have to add on 20. Because I want to make sure I remember that. Now it says it's $3 per person, so I'm going to add another column, which is the number of people. And F is supposed to be my number of friends. And it says that I'm supposed to do 5 to 12 friends, so I've got 5, 6, 7, 8, 9, 10, 11, 12. And it's okay that we run out of room on the table. We can add more rows to that table. That's no big deal. So don't stress about that. I'm supposed to have C as my total cost. Now, what I haven't found yet is the cost of just the friends. I've got the $20 flat fee, but the friends are $3 per person. Okay, so I need to take the number of friends and I need to multiply it times 3. So this column here is going to be 3 multiplied by the number of friends, because I've got the total number of people in the group that I am representing using the variable F. So this is the straight up flat fee here. So this is going to be the cost per person. If I've got 3 people, it's going to cost this much. If I've got 10 people, it's going to cost this much. So if I take 5 people, 3 times 5, that's going to be $15. If I take 6 people, that's going to be $18. 7 and 3 is 21. 8 and 3 is 24. 9 and 3 is 27. 10 and 3 is 30. 11 and 3 is 33. 12 and 3, 36. Okay, so I've got all my parts here now. I've got the $20 flat fee that I have to pay, and then I have the $3 per person, and if I bring this many people, this is what it costs. So to find the total cost, I'm going to have to take the 20, and I'm going to have to add it let's see. Okay, I'm going to take the $20 and I'm going to add to that 3 times the number of the people in the group, the number of friends. So I've got 20 plus 15 is 35, and I've got 20 plus 18, which is 38. Now I could also see this as 3 times 7 is 21, plus 20 is 41. But I've broken it into these nice little parts so I can see what's happening here. And there is the cost for 5 to 12 friends. If I take 5 friends, I have to pay $20 plus $15 because it's $3 for each of the 5 people for a total price of $35. Let's look at exercise 4. Carlos is shopping for school supplies. He bought a pencil box for $3, and he also needs to buy notebooks. Each notebook is $2. Let T represent the total cost of the supplies, and N be the number of notebooks Carlos buys. Now, I just heard here that $3 isn't changing. He bought a pencil box, $3. So at the front here, I'm always adding $3. I'm going to write that down because that's a flat fee. It doesn't change. He's buying one pencil box. It's $3. He has to pay for it. What is going to change is the number of notebooks. So that's going to become our independent variable. And I'll use N for the number of notebooks. Now the cost of the notebooks, they're $2 each. So that's 2 times N. So my total cost is going to be, I'm supposed to be using T to represent the total. So my total is going to be the $3 for the pencil box plus the cost of the notebooks, which is 2 times each notebook. So I've got 1 notebook, 2 notebooks, 3 notebooks, 4 notebooks, 5 notebooks, 6 notebooks. But I'm supposed to do 1 through 5. Okay, I can do that. So this is the cost of the notebooks. And this is the total of all the supplies. So if I've got 1 notebook, 2 times 1 is 2 plus 3 is 5. If I've got 2 notebooks, 2 times 2 is 4 plus 3 is 7. If I've got 3 notebooks, 2 times 3 is 6 plus 3 is $9. If I've got 4 notebooks, 4 times 2 is 8 plus 3 is 11. If I've got 5 notebooks, 5 times 2 is 10 plus 3 is $13. Now this time I didn't show all of the in-between work for finding out just the cost of the notebooks. I've condensed it down showing just one nice little step here, the number of notebooks plus the flat fee. If it makes you more comfortable to break it down into these separate columns, go right ahead. That is okay. You can do that. The big thing here is to think deeply about what's happening. Represent it well. All right, closing. How can you determine which variable is independent and which variable is dependent? The dependent variable is affected by changes in the independent variable. The independent variable gets to do what it wants to do. And when it changes, the dependent variable has to change too. It doesn't get to choose when it changes. You can also write a sentence stating that one variable depends on another. For example, the amount of money earned depends on the number of hours worked. The total cost of the school supplies depends on how many notebooks are purchased. So the money earned is the dependent variable, the number of hours worked is the independent variable. Looking at the I can statements, hopefully you are feeling pretty comfortable that you can identify independent and dependent variables. Write an equation to represent the situation. Create a table having the independent variable in the first column and the dependent variable in the second column. And then substitute in some values. Put in some values for your independent variable, evaluate your equation to find what happens to the dependent variable. So that big scary learning target, analyze dependent and independent variables, turns out to not be a big deal. We have used tables to look at them, and we have also connected them to an equation. Graphs are coming, but it's not a big deal. We got this. And we are writing and solving. We did a lot of writing and solving of equations representing real-world problems. So that concludes Module 4, Lesson 31. If you have any questions, make sure you reach out to your teacher. Make sure you complete your problem set and your exit ticket.